Can everyone see screens and everything all right? Yeah. Okay. Well, yeah, welcome to CPD 43. It's Gareth here from the Wessex region. We're here for the data-driven approach for net zero building, CPD 43, and I'll pass you over to Josh. I believe he's going to introduce us.
I think Kemi's going first, actually.
Sorry. Stop sharing.
I'll just try to share my screen. Hopefully that's working okay.
Yeah, I think that's all working okay.
Okay, hello everybody and good afternoon. As Gareth said, I'm Kemi Adeyeye. I'm an academic here at the University of Bath, and I'm doing a double act today with Josh Shimmin, who's at Atamate, and he'll introduce himself properly later, but we do work quite closely with Atamate, so it's quite nice that we can both do this together. Okay, so yeah, we'll be talking about data-driven approaches to net zero buildings, and now we'll start by sort of giving a contextual view as to where we come, how we're approaching this, especially from the Bath perspective and how it affects the sector. And I'll also present a short outline of a research project that we've just concluded at Bath, and then I'll hand over to Josh, who will talk about the actual practicalities and the technical aspects of performance monitoring within the context of their projects. So we hope that the presentation is a nice round view of some of the practical policy, but also technical aspects of data-driven performance monitoring, especially in the context of achieving net zero. Okay, so this is a diagram of that I've taken from the UK GBC, the Green Building Council, and this is their update on the roadmap to net zero for the sector in the UK. And as you can see here, we've actually been doing quite well, and most of us would have seen the news that the UK is one of the first countries to achieve the net zero target. So we're doing quite well. There's a nice downward trend there, especially since the 1990 levels. The mark in the middle sort of shows where we are at the moment. So if I can find my pointer there. But we can see that we need to continue this downward trend to get to net zero by 2050. But this is quite a curious thing that is happening here, that we're seeing a little bit of a flat line in the trajectory. So that's a bit of a worry there. And from my point of view, there are a few explanations for this, and it's sort of why are we lagging? Why are we sort of having that flat lining if we're sort of doing the right things, and especially within the building sector? So a couple of charts, because I'm particularly interested in the impact of the current building regulations and standards and metrics that we use, especially since what we call the modern regulations, 2010s onwards. And again, we can see that downward trend, but again, we can see that some of the impacts are working in terms of electricity and gas consumption, but we're sort of achieving about 8% decrease, 8% to 11% decrease, and then no more. And it's quite strange that why is that the case? The reductions here are due to COVID, but we've since seen a bounce back in consumption. So there's that slight upward trajectory there as well. And the same is true for the non-domestic sector, which is actually quite curious, because in the non-domestic buildings, electricity and gas consumption is sort of relatively constant since 2012 to 2019. So it's sort of stayed around the 8% mark, but we've not really been able to achieve real change there. And there are quite a few reasons for this. We could say that the reasons are because of some of the nature of carbon counting, and the metrics that people use for that. We've mentioned issues of COVID and the fluctuations that we have in that, but we're also seeing a volatility in the impact of the common interventions that are used in buildings. So the diagram at the bottom sort of talks about the impact of insulation, solar PV, loft insulation, and so on. And the volatility in the data is quite curious. And some people have tried to explain this. That is because we don't have enough data sets, and I sort of subscribe to that view. Most of the data sets used in the government analysis tends to be based on small sample sizes, and we don't really know is the long and short of it. We don't really have a full picture because we don't have performance monitoring as standard across the sector. People do it in a very piecemeal fashion, but there is no repository like you will have, say, for health and safety and so on for how buildings perform. So at the moment, we are proposing regulations, we are having lots of models, but we don't really have a mechanism for measuring what the impact is, and we propose, and there's now a tendency towards more renewables, air source heat pumps, but we don't really have an evidence-based approach to underline those things. The second issue that we have is the issue of the performance gap, and most of us in the sector probably are quite familiar with this. We have performance gaps between new and existing buildings. We have performance gaps between the design, forecasting, versus what happens in reality. And again, researchers here at Bath, we found that a new building could be 250% more energy intensive than what the models predicted at the early design stages, and it's prompted Letty to actually say that, you know, you could have a building that is 2020 Part L compliant, that is performing worse, and in terms of performance is worse than a building built in 2013. And the question is, why is that the case? Is it because we don't have the evidence? Is it because the pollution measures are not effective? Or is it because the mechanism that we're using in industry themselves are not effective? But also there's a lot of evidence to suggest that this performance gap sort of aligns with the various stages of the RIBA plan of work. And it sort of centers around that lack of evidence, that lack of analysis, and the lack of feedback in our processes. So, and this diagram here by other researchers sort of shows that there are basically three routes to this. One of them is the regulation, and that's what I'm emphasizing. But there's also the static performance gaps, which is based on, you know, when you get sort of around here, you sort of introduce a problem because of the way we design and the decision making around modeling and simulation, but also decision making around what we value during the design process and how that value translates to reality by the construction phases. And then you get the dynamic performance gaps when you get to the occupancy stages, and it sort of stems from how we commission buildings, but also we don't optimize our buildings. We sort of design them and live them, and we expect everything to work. There's no mechanism to optimize performance as we go. We don't interact very well with users. We don't get the feedback from the users and then feed that back into the design process. So there's a lot of what ifs in the design decision making, and you know, what of and how. And this has prompted Letty, which I'm a big fan of, and probably quite a lot of us are aware of, to sort of introduce this data disclosure stage to net zero and whole life carbon approaches, and they probably were amongst the first to sort of highlight this issue of the lack of data disclosure across the sector, that if we're going to actually achieve what we want, which is sort of this net zero whole life carbon net zero issue, then we need to actually have scalable data, which basically says that we can't keep forecasting policy and regulations based on a handful of buildings. We need to scale it out across the UK and actually know what the buildings are doing, old buildings, historic buildings versus modern ones. And we need to be able to verify those data sets as we go. And data disclosure is very much rooted in post-occupancy evaluation, which everybody knows about, and building performance monitoring is a subset of that, but which we all do quite well across the sector. But we generally don't do the last two parts, which is that closing of the loop to better inform building standards and just connecting the dots between what we all do and how we do it and good practice, and then feeding that back into policy and regulations and better practices going forward. And the EU, just as an example, are beginning to do this now with what they call the Smart Readiness Indicator, which came into being in 2018 when they did the revision to the Energy Performance Building Directive. And most buildings now across some of the pilot countries in the EU have to have a sort of smart outlook to buildings, which allows them to optimize the technical systems in the building over the life cycle. So if he's not achieving, so don't rely too much on the models and simulations, you know, you sort of do sort of like an active design process where, you know, you go back into the building and you can tweak systems and processes to achieve the desired effect. So, and smart systems allows you to do that. But it's also about that better engagement with the occupants of the building in terms of their needs, comfort, convenience, health and well-being, but also feeding back and gathering information from occupants back to those that set the policy, or to people like us who are designers and professionals in different capacities. And of course, it also allows you to do the infrastructure part, which is basically optimizing what happens in the grid as well. So smart buildings are all great and fantastic, and there are various iterations of that within the Internet of Things milieu, where people can now buy different bits of kits that do each one of these things, either to a little or a large extent. So you can all do them in a separate standalone system, or you can do them in a connected manner. And in not domestic buildings, probably with facilities management, probably do it in a more connected manner with building management systems and so on. But again, we're more particular about this part at the bottom, that, okay, what's happening with that data? Who gets that disclosure? Who gets access to that information? And for that to happen, we need to engage with stakeholders really across the sector, professionals, design professionals, but also facilities managers, clients, and user groups as well. And the idea is that if we combine smart buildings with performance monitoring, does that mean we actually achieve better trajectory towards net building? But there's a fundamental question, which is really the big elephant in the room. Will people be willing to share the data? You know, will you, especially in the domestic sector, want to have sensors sticking all over the place in your house, and then somebody having external to the home having access to that data? So there is some work to be done in terms of privacy, security, and the infrastructure and architecture that goes around smart readiness, but also that data disclosure aspect. So we did a study, and I'll round up because my bit is actually the short bit of the thing, and Josh's part is probably the most interesting bit. But to address that data disclosure issue, we did a national survey, a national study rather, which was included a survey, interview, and focus groups of about 972 participants, and we found that there was generally a high level of awareness across the sector, and people said, well, we're not even doing this a bit more. But generally, people would adopt smart systems, but not just smart systems, it's systems that sort of do the performance monitoring. So it's not just gadgets and gizmos within the home. It's about that holistic performance monitoring, feeding back to the occupants, feeding back to professionals, feeding back to policymakers. And there was a general positive reception to it, with the exception that people would do it if it was pre-installed. for example, which makes a lot of sense because nobody wants to be tinkering around with technology that you don't really know it much about. So there was generally that perception that it has to be easy, it has to be safe, it has to be affordable. A majority, again, sort of more than half, will say they will do this data disclosure. So they'll be quite happy for the data about the performance of their homes to be shared externally with lots of conditions, and most of them centered around privacy and security. And the question was whether really you could trust the system not to be hacked. Reasons not to adopt is mostly centered around cost. And again, that's not much of a surprise. And people said, actually, we would pay for it if we could understand the benefit, and if it was linked in with other services, say, for example, like broadband provision, which most people have now in their homes, and is provided as a service. You don't own any of the boxes. You don't own any of the wires and everything. It just sort of arrives, it works, plug and play, that kind of system, and they'll be quite interested in that. Cost being an issue was very recurring, but it was interesting that people would actually be willing to pay for stuff if, again, there was a clear benefit to it. So, and if it was aligned with something else, or like I mentioned, with the utility companies and the broadband providers, or if it was incentivized by the government. And they would like a certified tradesman scheme, so that it's not just anybody in your home installing things. What was interesting, just to start to round up, is who would they share that data with? And generally, people were quite reluctant to share data with building professionals of any kind, but will quite be willing to share with utility companies and perhaps the government. But if it was related to things like council tax, so it has to be linked with some service based approach. So the outcome basically was that we then proposed a rule-based data sharing, data disclosure protocol, and I'm quite happy to provide this in a lot more detail. But it was basically in 3 stages, where you have no data disclosure at all. Stage 1, stage 2, you have some disclosure, and stage 3, which was important, you can trade that data for a benefit. So, and that's where that aligns with things like utility companies, broadband providers, where they get a service and they disclose part of their data for that service in exchange for some financial or a service benefit. So that's my outline, and basically what we think actually is that as a sector, if we're going to start to sort of stop the flatlining of our downward trend and actually transition to net zero better, there is some information processes that we need to put in place, and we need to start seriously thinking about data disclosure, performance monitoring, and smart readiness of our buildings as part of a package that allows us to better transition to net zero buildings. Over to you, Josh.
Great, thanks, Kemi. I'm just going to share my screen. Is that done it?
Yeah.
Great. All right. Yeah. So as Kemi said, I'm Josh and I work for Atamate. I'm actually a building services engineer by background. So I come from the sort of the world of building design and architecture, but I work for a company called Atamate now. We have 2 sides to our business. Our main side is we provide a building monitoring and control system. So an example of what Kemi's just been going through. We also have a second side to our business, which is the kind of Atamate consulting wing as well, which is where I sit. And that's about not just selling these systems into buildings, but also understanding what to use them for, how to improve them, what to do with the data, working with clients to try and work out where do we move forward with this kind of thing. So that's our business. So what I kind of want to run through today is sort of give you an example of, well, give a bit of experience from our business and talk a bit about some of the challenges behind collecting data, what does good data look like, and potentially what benefits are there from using data. So in terms of the challenges of collecting data, I mean, it's actually quite difficult, if I'm being completely honest. So things like low budgets, like Kemi's already alluded to the fact that there often isn't much money available at the end of projects for this kind of thing. Also, there's no real regulatory benefits at the moment, so there's no system in place that actually puts a sort of persuades contractors or building owners to put this kind of stuff in. And things like Part L or the processes of SAP that govern domestic buildings, don't recognise this kind of kit, and there's no benefit for doing it. So really, it comes down to having engaged people who understand the benefit of these things to make it happen. So we're very reliant on working with partners to try and work through what the benefits might be. Also, things like having siloed systems. So there's lots of different types of systems in a building, which I'll run through very shortly. And there's loads of data to be had, but whether you can get at it is the question. So quite often there is data there, but we're losing it all the time. So it's how do we get all of that data so we can do something good with it? Often people talk about it being too expensive, and that comes that goes hand in hand with low budgets, and it being there is added complexity with these kind of things. Our worlds are getting ever more technical and complex, and that's not always the right thing, but there are also benefits to be had as well. And we're dealing with people at the end of the day, so we've got to take everyone on a journey if we're going to make these things happen. So there's plenty of challenges there for us to overcome. But when we talk about systems, they are quite siloed. Generally in a building, you get different types of systems. I mean, you could be you say BMS there, but we're typically talking about heating, ventilation, air conditioning systems. So we're talking about temperature control and ventilation control. So air quality and thermal performance is quite key. Then there might be lighting systems in your building. I mean, this could just be switching on a light, but even that is a data point in itself if someone switches a switch. Access control and security systems also, they're very sensor driven, but that sensor information is used for very specific things, which are quite siloed. And then more and more we're seeing metering becoming a thing. With the introduction of smart meters, a lot of our domestic buildings, I think it's quite a high percentage we're up to now, have data just sitting there that is there to be looked at. So at the building level, we've got various different systems which have data to be had. And then some of these systems do have ways of getting the system out into a cloud or something like that. They might have a proprietary system that allows access to that data either locally or via the web. And then we might be able to pull that data out to a third party so that we can see what's going on. But it's pretty hit and miss that on a building by building basis, especially in the domestic sector. It's very uncommon to get that kind of level of stuff. So at Atamate, what we try and do is we try and just unite all of these systems onto a single platform. And we call it a single pane of glass. If we can get all of the data in the building into one place, then we can start to do interesting things with it. So we have a hub in the building, we collate all that data together, and then we push it onto the cloud. And from there, we can then manage it in the way that we want to. And we can then interact with third-party systems like a facilities management or a property management system, depending on the size of the building or whether there's a portfolio or not. So there's definitely some benefits to be had from being more holistic in that sense. But it has to be simple. It has to work. I mean, Kemi's gone through sort of various sort of challenges and sort of perceptions around these kind of things. And one of the things is one of the big barriers is, especially from a retrofit point of view, is how do we get it into the building? So yeah, we need it to be installable by electricians. We kind of want to avoid specialist subcontractors as much as we can, but they do exist. We want to involve having to have specialist programming, so you're not relying on controls experts who are incredibly skilled, but in a small number. And then we want to kind of get it to the point where we've got all the information in the one building in one place. We also want to try to avoid having to run lots of cables around the buildings, because running cables, especially after a building's built, is a very expensive thing, and actually a lot of the costs can be in simply making good rather than the actual building control system itself. And then it has to be simple to use. So this idea of user interface is very important, and we're doing various different types of user interfaces at Atamate. sometimes we find that the simplest ones work the best. So think even something as simple as having a button on the wall that says heating boost, so just push it when you're cold, and that in itself gives us a data point. How often is that button being pressed? The building can learn from that. And it needs to be intuitive. It needs to work for the person who lives in that building. So it also has to be simple to maintain. And what we're finding is that it's not just about having dashboards that people can look at. It's about having alerts. How can the data tell you what's going on when you need to know it? So be able to perform routines on the data, raise alerts so okay, this is a high priority, something I need to act on, or actually I can leave that for now, or I'll just wait for the 10th one to happen, and then I'll know that I need to do something. So we can prevent issues from escalating, but we can also manage the building going forward as well. So so at Atamate, this is a kind of overview of our system architecture. We've really got sort of 4 key products that we offer. The first one, and the kind of main one, is the one you see. It's the devices. It's the things that sit in the building itself, and that's in itself, as Kemi says, that's that's something to be overcome, and you have to work with the people within the building to understand what's acceptable and what's not acceptable. But generally, for us, that involves sensors. So that could be a sensor on the ceiling that's picking up the conditions within the space, or it could be a meter that's picking up how much electricity has been used. And then that is the thing collecting our data, but then we can do stuff with that data once we've got them. So we then have things like actuators that allow us to switch things on and off. And then we also might need to take that data and to transfer it into a different form. So all of our devices communicate with Bluetooth to avoid wires, like I said before, but then we might want to talk to a specific air conditioning system that only speaks a particular type of serial language, for example. So then we need to have gateways that transform this data around. So we're moving data around the building. We need hardware to be able to do that. Within that hardware, we've got control apps. So that's using that data to do things like control air quality, to control heating, that kind of stuff. And then above that, we've got data apps. So that could be doing things like maintenance routines, could be doing analysis, that kind of stuff. So that's when we start to really get the use of this data. And then we have a 4th product, which is the one that we don't that's rarely seen, which is a design studio. So it's how do we configure a building? How do we understand what sensor is in which room? And we've developed a way to do that that can be done by an electrician. So what does get good data look like? So yeah, as I said, it's not just about monitoring. There are things we can do with that data too. So control is the key one. Is can we use that data to run that building more efficiently and act at the point when we sense that there is an issue. Then there's an operations opportunities. So that's really about management and maintenance. So running that building better so we can make it more efficient in the long run. So that's kind of medium term. And then there's this sort of strategic analysis performance. So that's, can we track the data? Can we see what the performance is over a given time? Can we see if that performance is degrading? What are the key things that we want to get out of that data? So there's sort of 3 very different sort of ways of looking at data in that sense. And then there's really we kind of see there's sort of 5 main value propositions from the data that we're collecting at Atamate. Now, the key one, the one that we always talk about, is the easy one, is the energy one. And energy is obvious, especially from a trying to reach a net zero. Energy is key. We all know that, and we've got various ways of trying to work towards that. But there's also trying to make the building more comfortable as well. So wellness and comfort is a really big part. We don't want to make buildings that are really energy efficient, but they're not comfortable, healthy to live in. So understanding how we use that data to make better buildings as well. Maintenance I've already talked about too, and then things like security as well. So entry control, understanding who's coming in and out of those buildings. Using that same data to knock down insurance premiums. Looking after elderly care or people with specific illnesses. That we can do some quite clever things here. So it's worth not overlooking them. And then also managing those buildings too. So setting routines. Making it so that we can allow access at certain points of the day, or setting the heating system to pre-warm a space or something like that. So there's various things we can do. But the key factors influencing energy consumption sort of comes down to 3 main areas. There's the key one is the humans, and it's sort of the people element, and that's often actually overlooked in building design. And really, that's a key part of the performance gap that Kemi mentioned before. Then there's the building services. It's the systems inside the building, and then there's the building envelope itself. So it's what is the building fabric made of, and all that kind of stuff. And it's the interface with all these things is where control and data is really interesting, especially within the context of the climate and what's going on outside the building, and this sort of dynamic versus static effects that Kemi was also mentioned. So we've had a lot of success kind of linking occupancy with control, so using data to make that bridge. So things like occupancy-based heating, ventilation controlled on air quality, so demand ventilation, and making it very user-centric in terms of the control. So we can show that actually if you use occupancy-based heating, so you only turn heating on based on whether the space is occupied, you can reduce energy use for heating sort of 20-30%, and that's considerable. If we're doing that across our whole building stock, there's potential to do some pretty impressive things there. You can also do things like manage energy demand. So especially in a world that's moving towards low carbon ways of generating electricity, so renewables, we also need a way to manage demand, and so that's understanding peaks and understanding battery storage. So you can use the data in terms of when energy has been used to basically knock off the peaks of your consumption, because basically you have to design a building to have enough capacity to deal with the biggest load. So if you can reduce that load, you can make the capacity smaller, you can make things run more efficient. So we also need it to be flexible. So we need it to have bespoke enough so that we can do clever things with our data, but we need it to be not so clever that it's not accessible. So there's trying to find a balance there between what kind of functionality we can get with making sure it's understandable and accessible. So we're trying to develop ways to do that too. And when it comes to retrofit, especially, there is a lot to learn from the buildings that were already built, and really, data is key to that. Is getting the sensor data and to understand how a building works first. That there is only so much a model can tell you, whereas if the building's already built, you can get that data and you can see what's going on, and that allows you to do things like simple wins, upgrade your building, and then think about offsetting. So data's got a big role to play in our retrofit future. So also things like improving air quality. So we know that if someone walks into a room, the CO2 levels are going to go up, but how much? So we can use data to understand that. So here's a trace of occupancy versus CO2 levels, and you can see how well the ventilation system is performing. Are the buildings that we have good enough? And we can start answering those kind of questions with data. And we can see in real time what's going on. So things like relative humidity levels, CO2 levels, what's the temperature really like inside a building? Is it comfortable? Is it not? Is it healthy? Is it not? And what are causing those issues? So data is key for that kind of thing. Security I've already mentioned. So so I'm going to skip over this one, but there's definitely sort of hidden benefits of using data from a security benefit as well. And a big area that we're growing into at the moment, which potentially has more of an impact than the control side, is maintenance and asset protection. Is especially in existing homes where there's problems with condensation, damp, and mold. Maybe there are systems that aren't working effectively because their performance has been degraded. Maybe there's issues that sort of process issues where we're having to call out technical professionals to come and fix an issue actually that could just be sorted by flicking a switch. So trying to minimize cost and time for contractors, we can do that with data and do that way. And then interfacing with systems like fire alarms or security alarms to know when they've gone off and why, and trying to link that to what else is going on in the building. So there's a lot we can do around maintenance and asset protection with data. And then management as well. So looking, if you've got a portfolio of buildings, trying to manage across them, start to bring benchmarking data out for those buildings. So we can compare, like Kemi said, we can improve those data sets, make those data sets bigger so we can understand what those benchmarks are. And once we've got those benchmarks, we can see what the outliers are and where improvements could be made, and therefore lead to improvements in the future and getting towards that net zero carbon target. And then also disrepair claims. It's not a lot of what we see in the industry. It's driven by money. And that's not surprising. But if we can find ways to support clients to protect them against repair claims and to make their buildings better for their clients at the same time, then everyone's going to win. So we've got to keep this sort of founded in what the drivers are for the people who own these buildings as well. So there's definitely a lot we can do around that too. That's kind of all I want to say. So I think, Kemi, I think we're open to questions now. Is that right? So thank you very much.
Hi. Thank you guys, Josh and Kemi, for that. I think it was really interesting. I mean, yeah, we'll open it up to a short few questions now. With a few questions too. Do you think that with the inputting of the systems, is there like a dominant building typology or industries that are, you know, such as like public sector buildings or you know, warehousing like Amazon's and stuff like that are trying to, that are more sort of financially sensitive or driven by inputting these sort of systems?
I can take that one. Yes, is the answer to that one. I mean, it's really clear to us that the domestic market is much more difficult to get into than a commercial sector, for example. We see it's a different perception. So things like a commercial building where you might already have a building management system in already, which has controls and monitoring equipment in, that's accepted. That's accepted that happens. And you know, so really it's about making those systems better and working with the individuals within those businesses to make them better, especially as you're generally dealing with a smaller group of people who cover more buildings at once. So the level of knowledge and understanding of the kind of issues that we're talking about is much easier. In the domestic sector, you don't typically have these systems already, and you might be dealing with a one person per house kind of question. Now that's a much more, from a technical and sort of process, that commercial process kind of standpoint, it's much more difficult to roll that out and scale. So the barriers are much higher. So what we're trying to do at Atamate is trying to get the functionality of a building management system, a price point that can go into domestic buildings, and that's the challenge that we're seeing. Where we're seeing a lot of traction is in buildings which are very repetitive. So like student accommodation, for example, you know, that you've got the same room over and over and over again. Then you know, there's scale to be had there, so it's easier to make these things happen. So yeah, so that's our experience with those kind of things.
Just to add to that, I would say for the domestic sector, one suggestion that we keep having is that some of these systems should be pre-installed, especially in the new build sector, and that sort of overcomes that barrier.
Yeah, I suppose in the sort of domestic sector, that people getting more used to having access to that sort of information, with, you know, the wonders of the British Gas smart meters and stuff like that sitting on the sides in their kitchens, and especially the cost of things at the moment, constantly looking at it. So to have something in the house, we say it's pre-installed, then it's simplicity, I think, isn't it, and reliability for them to be able to access it. Yeah, as you say, it's the commercial side that people are used to it, aren't they? The fewer decision makers having a bigger impact. Any other questions and stuff from anybody? Seems to be quite quiet. Well, I hope you found that. Thank you so much to Josh and Kemi for today. I hope you all found that sort of interesting and informative. Yeah. With regards to next month, just share the screen. So next month we've got James Banks and a couple of the guys from Society of the Environment coming in to talk about sort of the CEAT Chartered Environmentalist sort of chartership route, and to discuss the way, means, and hows to and benefits of that level of chartership for you. So yeah, that's 6th of March, 1 o'clock. The sort of sign-ups will be in the usual place on at the moment on the CEAT main website, but you'll log on to the socials as well, it'll all be there for you. But yeah, so we'll just like to say, yeah, again, thanks ever so much to Josh and Kemi, and see you again next month. Right. Thank you so much for it, guys. Really good.
Cheers. Thank you.